Alright, so today we're given an equation here, quadratic equation. F of x equals negative x squared minus 4x plus 2. And we're going to find, whatever it has. Bunch of its opening, the y-intercept, axis symmetry, vertex, min and max, domain and range. Almost everything we can find given just an equation. Okay. Alright, I want to identify what A, B, and C are first. Okay, the equation given to us is in standard form. So we're going to find A, B, and C. A is always in front of x squared. Well, there's no number in front of x squared. Doesn't mean it's 0. It's negative. There's a negative sign there, and it's actually a negative 1. It's negative 1x squared. Okay. B value in front of x is negative 4. Again, whatever sign is in front stays with that number. And then C is the constant at the end, which is just 2. Okay. All right, well, the first thing we can say about this graph is that we know the opening. We know it's going to open down. Okay. Why is it going to open down? Well, because your A value is negative. Okay. Since A is less than 0, A is negative, it's going to open down. All right, another thing we could find without any work is the y-intercept. The y-intercept is always the C value. Okay. So your y-intercept is going to be at the point 0, 2. Point this arrow the other way. All right, the axis of symmetry. We're going to use the axis of symmetry formula. Axis of symmetry formula is x equals opposite of b over 2a. Okay. And we'll just plug in the values for a and b. Okay. B is 4. Okay, so the opposite of b. The opposite of b is negative 4. The opposite of negative 4 is positive 4. Okay. So we're going to have positive 4 over 2 times a. A is negative 1. Okay. Simplify. It's 4 over negative 2, which is negative 2. Okay. So our axis of symmetry is x equals negative 2. Okay. The vertex. Since we know the axis of symmetry, the axis of symmetry is also the x value of the vertex. So to find the y value of the vertex, we need to find f of negative 2. Okay. We need to find the output when the input's negative 2. So the y value when the x value is negative 2. So we plug that into our function. It's negative 2 squared. So careful there with the double negative. Minus 4 times negative 2 plus 2. Okay, so careful simplifying this. Negative 2 squared is positive 4, but then the negative's outside, so that's going to be negative 4. Negative 4 times negative 2 is plus 8. And then plus 2, so it's going to equal 6. Okay. So our vertex is at the point negative 2 from the axis of symmetry, 6, which is what we just found. Okay. Now, since our quadratic here, it opens down and we have a vertex at negative 2, 6, that means we're going to have a maximum value at 6. Okay. So our highest output, our highest y value is going to be 6. Okay. Again, we know that because the graph opens down, which means the vertex is going to be the highest point. Okay. All right. Domain and range. I want to make sure this isn't, you don't think this is an interval for the domain. Domain's always all real numbers. Okay. Unless there's some constraint given to you. Any quadratic polynomial, any quadratic is going to be all real numbers for domain. Range. Since we have a maximum, that means the highest value is going to be 6, which means every y value is going to be less than 6. Okay. Well, how do we write that? Well, you simply write y is less than or equal to 6. Okay. All right, and we're going to graph what we have and see if we need additional points. We know the vertex is negative 2, 6. Okay, my graph's a little short. So I'll just put that up here. I know the y-intercept is 2, so we can graph the y-intercept. Okay. And then I'm just going to also lightly and with a dotted line draw the axis of symmetry at -2. Okay, so that visually and it helps us graph it because we're going to reflect any point that we have over the axis of symmetry. Okay, so I did it in light color. So we're going to reflect the y-intercept, which is 2 away from the axis of symmetry. We're going to go 2 in the other direction, put a point. All right, so we have 3 points, and that's enough to draw it. Since my vertex is not really on the graph, I do want to get another additional point. So I'm just going to pick one. Well, I know that the x value is at -2, and I know it's 0, but we're missing this in-between spot. So I'm going to find f of -1. Okay. So when my x value is -1, what's my y value? What's the point? So that'll be -1 squared. Again, same with the when we're finding the vertex, careful with the negatives. -4 times -1 plus 2. So that's going to be -1 squared is +1, make it negative out front, plus 4 plus 2, right, which equals 5. Okay, so f of -1 is 5. That's going to correspond to the point -1, 5. So we go ahead and plot that, which is all the way up here. And again, we could reflect it over the axis of symmetry. All right, so now I have 5 points, and we'll do our best to connect to parabola shape. Okay. All right, that's pretty good. All right, and there you have it. Find everything you need. If you need additional points, now again, at the beginning, you could just make a table. But without really knowing where the graph is, without knowing where the vertex is, you could pick points that are nowhere near. You could pick, if we would have picked like 1, 2, and 3, we wouldn't have had a good representation of the parabola. Okay? So it's always nice to find the axis of symmetry or the vertex first, and then you can pick x values around there.